First session of the day, so I have to do the sound check and be the sacrificial lamb. Good morning, everyone. How are we? How was the keynote? I was busy doing some last minute prep. It was great, right? It was awesome, fantastic, cool. I'm gonna have to check that out later. Welcome to NDC Melbourne. How many of you are local? Awesome. Isn't it great not have to travel to Sydney? You got the better coffee and anyway, let's not start that. Let's not start that today. Welcome to this session, Cloud Native Platform Engineering on Azure. My name is Velida. I am a senior software engineer at Microsoft working in the industry solutions engineering team. I'm very new, it's about a month in, almost a month now. Time is flying this year. Previously, I was a Microsoft Azure MVP focusing on Kubernetes and open source. Everyone was doing kind of AI-generated action figures. I'm much more into Lego heads, so I built some of the Star Wars Lego heads. So I thought, well, why don't I see if I can generate my own Lego head? Hopefully that doesn't terrify you, because I showed that to my fiance and she screamed, which wasn't good, not a good sign. I used to be a rugby player as well. Now I get my injuries through on-call like the rest of us. And I also do conference speaking and YouTubing online at youtube.com/Velida. So today I'm going to start by covering some of the current challenges that we face when we start to build applications in the cloud and how we might get a little bit of friction as developers and also between various different stakeholders within our organization. And then I'll talk about what platform engineering is and how it attempts to solve some of those challenges that we face. And then I'll cover how we can start to build platforms using Azure. So probably a good question to ask, show of hands, how many of you are deploying workloads to Azure? Most people in the room, fantastic. How many of you are deploying to multiple different clouds? So AWS, GCP, a few of you. Okay, cool, all right. This will be a very opinionated, here's how you build stuff on Azure. The underlining theory about platform engineering can apply to various different vendors as well, but I'll go, when we do the technical stuff and go through the demos, that will be on Azure. And I'll wrap up the end and there, hopefully leave some time for Q&A. So hopefully, well, maybe some of you will find some familiarity with this. So you're starting work on a project and you're starting to design what that might look like, where we're going to deploy it, how we're going to store our data, things like that. And you'll get a little bit of friction between various different stakeholders within your organization. So there might be security concerns and they say, okay, you can't do this, this, and this. We have weekly office hours. If you have any questions about your application, any concerns, come and see us at this time. There's also architectural patterns, cloud ops concerns as well. And then some organizations still have a particular DevOps team that do all the DevOps stuff, which kind of misses the point. They say, yes, we can set you up with a standard pipeline, but we'll need to have another meeting to discuss your requirements. And again, just as developers, you want to just get on and start building and start delivering value. It does seem to, even in 2025, to be a lot of friction just trying to build something. So this is where platform engineering comes in. Essentially, platform engineering is a practice built up from DevOps principles that seeks to improve each development team's security, compliance, costs, and time to business value through improved developer experience and self-service within a secure, governed framework. It's an idea of both a product-based mindshift set and also the tools and systems to support it. So think of your developers really as your primary customer and kind of focus on their needs first and deciding what development paths you want to pave or what development paths you want to enable. And I'll discuss a little bit of what I mean by paved paths in a bit. And also the capabilities that you want to grow. So essentially, we're giving our developers, rather than shifting too far left, where we're making our developers responsible for everything, so security, compliance, and costs, we want to empower them through self-service, so giving them the tools that they need, without worrying too much about having to build stuff from scratch, like governance, making sure our infrastructure is configured correctly. And also improve discovery and eliminate wastes through inventories. Now, inventories could capture a lot of different things. It could be catalogs. Who's familiar with Backstage? few people in the room, so it could be stuff like that. It could be fairly simple as actual repositories that serve as catalogs, and I tend to favor repositories over stuff like Backstage, because Backstage kind of fulfills a need, and there's a UI and it's all beautiful. But catalogs as repos is a language that developers can understand because it's code. Now, I do have a book which I do recommend. This isn't a prize, this is my copy. I'm not giving this out, sorry. So O'Reilly Platform Engineering. And it's good for developers, platform engineers, and also business stakeholders alike, because one of the challenging things about platform engineering, because it's an internal team, getting organizational buy-in can be a little bit tricky. So from a business perspective, the value that we get from platforms is really derived from accelerating that time to market while maintaining the guardrails required to operate within our business environment. And this could be different things to different people. So for those of you who worked in banking, maybe telecommunications, you'll understand that those kind of guardrails are strict and strict as a requirement. But there is more business value to writing the super awesome code and performant code that we write. We need to be safe as well. We need to operate within the environments that our businesses are running in. So the idea of platform engineering is trying to capture all those various different stakeholder requirements and make it as easy as we can for our developers to build stuff within that environment. So when we talk about different guardrails, they could mean a variety of different things. So really, it starts right from onboarding for team members, also project onboarding as well. So when you're starting new initiatives of work, how can you start right and stay right and also get that alignment as well? For large organizations, you may find that you have to call various different APIs and various different services across your organization. How easy is it for your developer team to actually find those services? Is it on some archaic SharePoint site somewhere with no requirements written down? Or do you go to something like API Center or API Management and call an endpoint? Things like that to really keep in mind. And it's also about cost optimization as well. So I'll talk a little bit about how we can actually optimize. We don't need to, it doesn't require a massive investment on our end to just buy a product and then deploy it, and then yes, we've got platform engineering. A lot of this stuff can be built on the pre-existing tools that we already have. So when we have that culture shift from product mentality, our engineering platform itself becomes the product, and developers are our primary customer. So we try to automate away as much responsibility from them as we can, with input from stakeholders like security, like architecture, like your business units or your product owners, so to say. So some teams do have the luxury of starting right, particularly with greenfield applications. Maybe they'll be able to, maybe they're following on from initial greenfield applications, where things have been set up correctly, so they can just leverage off that. Some have to get it right. So in the past, I've worked in organizations where I was part of a team where we were the first team to actually deploy stuff into the cloud. There's a learning curve to that for anyone who has been in that situation, and getting right initially does take a little bit of a challenge, bit of time, The point is that this is all a very iterative process. No two companies are going to be the same. So when you're building platforms, it's good to consider specific needs of your customers initially, so they're your first developer teams who are building applications using your platform. Through this, you're establishing a set of core building blocks that you'll assemble over time. So just to use a tangible example, you might be deploying your infrastructure through something like Bicep. You might be building the initial Bicep modules needed for your application. Over time, security is going to provide input, maybe the networking requirements as well. It's all an iterative process to build on top of that. And through that, you can ensure that you've got enough value for that development teams will then start to become advocates for your platform. So another team will come in and they're building a greenfield application. Rather than from them starting from scratch, they can leverage the stuff that's come before and build on top of that as well. And over time, you get that kind of buy-in for your engineering platforms. So it is a bit of a life cycle involved, and it does take time to iterate and make things better. And like the cloud, it is very much an evolving and moving target. Now, being Microsoft, if I can take my Microsoft hat for a second, we have a framework. We have a capability model for everyone. So hopefully you can see that, aka.ms PE capability survey. It's very similar to the well-architected framework where we ask you a bunch of questions. We can also read your environment as well. This one doesn't read your environment, so it doesn't connect to your Azure subscription. But essentially, it's a whole bunch of questions around certain capabilities. Excuse me. And it's really designed to assess where you are within your platform engineering journey. The idea here is very much like the well-architected framework assessment. It is an iterative thing. Not all things apply to all people, but it's a good measurement to see, okay, where do I actually sit in terms of my platform engineering capability? And different organizations will have different stages of maturity. So when you're starting, there may be a limited structure, there will be ad hoc processes, there'll be like a script that's sitting on some local computer, some sysadmin's computer, which he or she will just give to you, and you can just run, and then bang, you've got your developer set up there already. There'll be minimal investment in capabilities, so we do see that initially that platform engineering teams, when they first start out, there's not a lot of investment behind it. It is driven by individual engineers, and it's really just addressing the immediate needs of developers at that time. But the idea is, as you start to become more mature in your platform engineering capabilities, you may have dedicated teams addressing specific challenges. One of the things that the platform engineering book from O'Reilly does recommend, as you start to become more mature in your platform engineering capabilities, is not to introduce product managers or too many internal product managers into your platform engineering teams. The idea is still to address specific team challenges, but build your platform as you're going along. Now, your organization may have various different development paths to production today, and an early step in the platform engineering journey is to understand what paths developers want to use and want to take. So it might be you start out within your IDE like VS Code, you're deploying stuff to source control, you're running some basic checks, and that kicks off your CI/CD process, which deploys your application, both infrastructure and the application logic itself, and you might do some monitoring and observability. Over time, there may be more guardrails that you need to introduce from a security perspective, and it's really building on, and as platform engineers, understanding which development paths your developers need to take and building on top of that. Making this call is important because it allows you to focus your energy on paving those efficient paths through them that still meets the requirements of your developers' operations and governance. We can't talk about platform engineering without actually talking about security as well. So when you're developing your paved paths, it's important to try and integrate security at every layer. Again, this is an incremental process, and it does require collaboration from your security team professionals. Scalability as well is also important to consider, depending on what your developers, who are they building for. So a couple of years ago, I was really involved in multi-tenanted architecture design, where we talked about deployment stamps, where developers are building products for different customers and different set of customers who may need different resource requirements. And for there, they might share infrastructure amongst different customers. They might have dedicated infrastructure for specific customers, depending on their load. This is somewhat applicable to platform engineering as well for an internal teams as well. Having that scalability and understanding how your developers are building products it almost kind of translates to that as well for external customers. So some security considerations for our platforms, the need to implement proactive measures and ensure consistency. The one thing you don't want to do is almost have configuration drift between different teams within your organization, where one team is implementing security checks within their CI/CD processes, for example, and another team isn't. So codifying security configurations and policies is a good way to ensure that consistency is applied across all your teams. There's also considerations around identity and access management, also secrets and key management. A lot of this we can actually apply security and policy as code. So good examples of this: Azure Policy, Open Policy Agent, GitHub Advanced Security. These tools can actually enable codifying those security policies and then providing that at scale to different customers as they, different developer teams as and when they need to. And also applies in identity and access management. So integrating with your identity providers, you can use something called a teams as code pattern to actually define your teams within code as well, and then use similar mechanisms. So committing that to source control and applying that to Entra ID groups, for example. This is a good pattern to help you not just scale out for your developer teams, but also onboard new developer teams into your platform as well. So a little bit about monitoring as well. Monitoring is also going to be very important. This slide kind of covers how you do it at the technical level. One thing that I did neglect to put in here is getting feedback from your customers into the platform that you're offering. So part of that may be quantitative to see, okay, how many users are using this repository, how many users are actually using these services, do we retire some services and offerings as part of our engineering platform? A lot of it can be qualitative as well. So actually running, good old-fashioned surveys, might be a Microsoft form somewhere. Anyone use those? No? Okay, that's fine. To actually capture some qualitative feedback about how easy it is to use your platform. The important thing around monitoring, auditing, and observability in platform engineering is that since developers are your primary customer, it's important to listen to that feedback, enable good feedback mechanisms so they can actually help you iterate and enhance the platform and also make it easier to use. Now, just to break up the theory with a meme, there's a lot of things, so like infrastructure as code, team as code, etc. So there's a pattern, everything as code. The idea is you can actually define everything that you need, so security, governance, infrastructure, application, everything as code. The theory behind this is your catalog, so your repositories that you're actually committing to, so committing your team configuration, infrastructure configurations, etc. You can use your Git repositories to actually define that and use as a catalog. There's versioning control that gives us benefits such as version control, so we can track changes over time, security and auditability, so we can see who's making changes, why they're making changes, and it also allows us to actually implement a little bit of automation as well. And there's various different tools for this. So Bicep, Terraform, you can use for your infrastructure layer, Open Policy Agent, Azure Policy for your governance, etc. Cool. So how do we actually build all of this on Azure itself? So this is where I start to take a more of opinionated turn in this talk and start to talk about some of the actual technologies that we can use to start building platforms on Azure. So this is not meant to be, this is everything you need. This is just the different layers of how you can actually start to implement some of the stuff that enables kind of platform engineering in your organization. So really engineering systems, this includes things like what IDEs your developers are using, Visual Studio Code, Visual Studio, JetBrains, things like that. How they're collaborating with others, so through source control, what kind of source control you're using, how you're tracking your work items, how you're tracking issues, and how we're deploying our applications as well. So how we're going to perform good security scanning, how we're actually going to test our applications. Moving up into the application platform, so where we're actually running our applications. A lot of focus on platform engineering focuses a lot on Kubernetes, and I think that's a little bit of an overkill for lots of organizations. How many of you are using Kubernetes within your org? Okay, it's slightly less than half. How many of you are using stuff like app service, container apps? Okay, more people as well. I think one of the things that kind of gets overblown, particularly the literature that I see, is that platform engineering seems to be a Kubernetes thing. It really isn't. You just need to think about, okay, where am I deploying my applications? How am I defining the compute that I'm running on, and how can I make that easier for other people to use? Even at the application platform layer, there's also how can we apply security there? How are we using identities? How are we using secrets within our application? How are we controlling RBAC? And how are we continuously improving our applications as well? So what monitoring, what observability are we putting in place? And also ops as well. So when instances are raised, how are we resolving that? And how do we make it easier for all developer teams to buy into a particular monitoring or incident management tool that we're using? Can we onboard them easily? These are all questions you have to think about as well. So once we have an idea of how we're actually deploying our applications, what systems we're using, we can actually start to template this out a little bit. So we can actually build templates for what kind of application, what kind of infrastructure we're going to deploy our applications to, how we're going to onboard stuff, and you may find that you will split this up by discipline. So say a retail banking team who is just building front-end applications and back-end systems will have vastly different needs to, say, a data science team who will need larger compute platforms to run on. Maybe they'll need some AI or data specific services in Azure, AWS, wherever. And so we start to build out templates based on their needs as our primary customer. So starting from our developer coding environments, it's good to try and automate this as much as you can. Pre-configured templates and pre-configured environments reduce the chance for configuration to differ wildly between different developer systems. There's nothing worse as me, developer A, on my computer. I've set my computer up. And I've run installing software, and someone else gets onboarded maybe 2 weeks later, and they start everything from scratch. This can be done simply through PowerShell scripts or Bash scripts, something as simple as that. Maybe you commit that to a code repository and people just run that for the first time on day one, and they've set up their development environment. So this could also include source code, so what repositories they need to pull down, CI/CD configs, testing setups, really designed to actually ensure that security, monitoring, and collaboration tools are consistent across your developers within your organization. A good thing to evaluate before you start implementing or start looking at new tools is looking at what you have already. These are some of the tools that I use day to day. Yours might be a little different. How many people use Slack? A couple of you use Slack? Yeah. So replace these tools with what you're using. These are just tools that I'm using today. The point of that is evaluate how you can actually enhance and extend the stuff that you already have rather than building new experiences from scratch. Not only does this mean you're actually using the tools that your organization has already paid for, you're not spending more money, you're not asking your boss for more money, but it also helps developers not break their development workflow. If they have some of the tools, utilities that you want to continue may be custom, these are good candidates to enhance it. So it's a good say, okay, how are we using Teams? How are we using Slack? How are we using Visual Studio Code? Is there anything that we can do to build on top of that rather than trying to invest in brand new tools? I will start talking about some specific tools as well, which you may not know about. How many of you are using dev containers in Anger? A couple of you. Okay. That's good. So essentially what Visual Studio Code dev containers do is let you use containers as a full-featured developer environment. So you open your code repository within a container with all the pre-configured tools and runtime stack that you need for your code base. I've been using this recently for some Node.js. I don't really want to install Node on my computer. This is a brand new computer which I got from the States before the tariffs kicked in. That was great. No, I'm joking. And it's a good way to, say if you're moving between different projects or you're moving between different dev stacks, rather than installing it onto your computer each time, you can just basically open your code up inside a Docker container which has all the pre-configured tools and runtime stack that you need for your code base. One of the things I find with local scripts, even with dev containers, there can still be configuration drifts between different developers on your team. One product that kind of solves that is Microsoft DevBox. So DevBox is a service in Azure that gives developers self-service access to cloud workstations called DevBoxes. With these DevBoxes, you can pre-configure tools, source code repositories, pre-built binaries, etc., that are specific to the projects your developers are working on. So the idea is you can hit the ground running with a cloud workstation rather than having to install everything on your local machine. And it kind of removes that friction for waiting for security to approve a particular tool or identity to give you access to a certain site on SharePoint or DevOps, etc. You can use pre-configured images from the Azure Marketplace. You can use your own customized images. You can also use multiple DevBoxes as well for different projects. So if you're moving and drifting between different projects, rather than having all the tools on your local workstation, you can have a DevBox for project A and another DevBox for project B with different tools. And you can access it through remote desktop clients or web browsers if you find any issues with remote desktop clients. Cool, awesome. I've forgotten the tool or the application Windows 11, that's not great, but there is an application, I think it's Dev Home or Windows Dev Home, awesome, getting thumbs up, thanks Dylan, which you can use to connect to your various different dev boxes as well. So that's really from the workstation perspective. Now looking at the automation from an infrastructure as code perspective. So with your kind of large organizations who may be using something like Azure Kubernetes Service and they've got different clusters for different teams, that's all very complicated and can be overblown for teams who are much smaller. A lot of good platform engineering can actually be enabled through infrastructure as code. For smaller teams, it provides you that programmatic infrastructure management, Bicep, Terraform. Anyone still using ARM? Good. Writing JSON was never my idea of a good time. I better put the Microsoft hat back on. Or provide a way to actually modularize your infrastructure code so you can actually share that. And I'll go into a little demo on how we can actually achieve that. But it's a really good way of establishing those patterns that are required for your organization, not just from your application requirement, but also networking, security, etc., and making that available to other developers so they don't have to reinvent the wheel from scratch. And of course, with infrastructure as code, you get the benefit of being able to use CI/CD for automated resource provisioning as well. Now, taking that a step further, I'll talk a little bit about Azure deployment environments, how we can actually enable efficient resource provisioning to set up kind of test environments. You'll find that in some cases that developers want a sandbox environment just to have kind of like their own local inverted commas or their own sandbox environment to deploy their application code to infrastructure. Azure deployment environments provides a mechanism to do that. And then DevBox using that can also be controlled through your infrastructure as code, and then you can integrate that with identity management and policy enforcement tools to make sure that your workstations are compliant. There are various different approaches as well, so lots of you may be using a push-based approach where you're applying changes to your Terraform and Bicep code, and then you're just kicking that, just deploying that through CI/CD pipelines. It gives you that flexibility. There may be some manual intervention involved in that, so maybe you have a change review board that you've got to answer to. Maybe there's some security requirements that you need to just tick off before you actually push into production. So GitHub Actions and Azure DevOps provides those mechanisms to actually do some manual intervention involved. How many of you are using GitOps? A couple of hands in the room. So essentially GitOps is more of a pull-based mechanism where you're automatically detecting changes in your repository. The emphasis is really around declarative configuration and version control, and there is that ability to roll back to different commits to roll back changes to your infrastructure as well. ChatOps, is anyone using ChatOps in anger? Not a lot of hands. I don't see a lot of this too much in the wild, but essentially the idea is to really, it's not just specific to infrastructure management. It's also to your application code as well. The idea is you're integrating your resource management with collaborative tools like Slack, like Teams, so there are specific, what we used to call agents back in the day. We might have an agent for Azure pipelines or GitHub Actions where they'll say, hey, Will Velida has raised this pull request, please review it here. Or, hey, this change has now been successfully deployed to environment. That's basically some of the ChatOps stuff that I've used in the past. It really helps allowing tasks to be, or communicating changes within your pre-existing communication platform, and really designed to improve, I wouldn't say enhancing user experience too much. We don't all like too many Slack and team messages, I don't think. Slack does have a nicer ping to it than Teams. I didn't say that. But it was really there to enhance operational efficiency. So rather than me bugging my friend saying, hey, review my pull request. Hey, this change has been made. Ping, 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 ping. The idea is that ChatOps kind of enables that for you automatically. The downside to that is, just like my messages, you can ignore messages coming from an agent as well. So things can be missed. So how you implement that, maybe you set up dedicated teams for your specific developer teams so that you kind of eliminate the noise generated from ChatOps mechanisms also helps. So in terms of myself and I as a developer, if I want to build kind of sandbox environments, Azure Developer CLI is really, really good for doing that. So it's an open source tool that kind of helps to accelerate the provisioning and deploying of application resources on Azure. So both for the application code and infrastructure code, we can use the Azure Developer CLI to kind of deploy that to our own sandbox environment. I'm getting hiccups on stage, that's great. So we define our application code through templates. There is some integration through GitHub Actions and Azure pipelines, but really in my to take an opinionated stance on this, it's really there to help accelerate. Here I am as a developer. I want to deploy this to kind of a sandbox environment. I have a subscription. I'm going to just use the Azure Developer CLI to go ahead and enable that. I will showcase how we can use private bicep modules to kind of share infrastructure and kind of help catalog some of the repeatable modules. I would recommend the Azure Verified Modules project. So this is an initiative by Microsoft to consolidate and set standards for good infrastructure as code. So for those of you who are familiar with the Azure Well Architecture Framework, Azure Verified Modules is really just a codification of that. So there are two types of modules, resource and pattern modules as well. And this is really designed to accelerate or help customers start off right, so getting the templates right initially with their infrastructure as code rather than having to build things from the ground up themselves. So do check that out. So one of the demos I will show, I'm just looking at the time, so Azure Deployment Environments allows developers to self-serve application and infrastructure through standardized project-specific infrastructure as code templates set by dev leads and platform engineers. So as platform engineers, I might have a template that sets up a particular application, rather than the developer having to clone that onto their local machine and having to deploy that themselves. They can use Azure Deployment Environments to deploy that template for them. And we can do that in a way that's, so our resources created are compliant, secure, and within good governance as well. One project I do want to talk about, how many of you have heard of Project Radius? So Project Radius is a CNCF sandbox project made from the same team, or created from the same team as the Dapper team, so Azure Incubations, headed up by Mark Rosinovich. So the idea is that it's a cloud-native application platform that works on any cloud. So if you think of Bicep modules or Terraform modules, essentially we define our applications as graphs through an application graph. We define it on particular Radius applications to environments. And underlining our infrastructure as code is something called infrastructure recipes. So you may have built up pre-configured existing modules, say for Azure Storage, Azure Service Bus, for example. Radius provides an abstraction to say, okay, instead of specifically saying that's a Cosmos DB database or that's an Azure Service Bus service, we essentially say, okay, that's a state store, that's a database, that's a pub sub mechanism. So the idea is it's cloud neutral across Azure, AWS, or any other cloud services, and we're defining our application as a graph so we can start to communicate and collaborate with different stakeholders such as security architects, rather than getting into the nitty-gritty of things to say this application is going to be hosted as a container, it's going to talk to this Redis cache, it's going to talk to this state store, database, etc. And then platform engineers look after the underlying infrastructure through recipes. Don't worry too much about the specifics. This is taken from our documentation on platform engineering. So developer self-service platform architecture, there may be some kind of UI or UX involved, speaking to a developer platform API, which is integrated with our own identity. There'll be graphs behind it, which will define, okay, what are our templates, who are our entities, so your entities might be your teams, etc. How are we going to orchestrate all of this, and then what's providing that? So tools, services like Azure Dev Center, Azure deployment environments could be a provider. You can drive this stuff out of GitHub Actions, ADO. You may have API catalogs like API Center, API management, where you enable that kind of discovery for different services in your organization. This all becomes part of your platform architecture. The good folks at CNCF have this reference architecture there. It's a little bit blurry, I do apologize, but essentially the idea is you capture your application model that's also kind of talking to various different tools. So your infrastructure as code, maybe technologies like Crossplane, Terraform. You may expose your UX or UI through something like Backstage. And then in Azure, there's something almost a little bit similar as well, where you can deploy Backstage as a container on your AKS. This is taken from an Azure sample, AKS platform engineering. It's very involved. I may not have time to show that to you today. But that's a very opinionated stuff. Don't worry too much about the specifics on the technologies being used. You can replace this with workloads that you're using, whether that be app service, container apps. But the idea is you're kind of splitting up elements of your platform architecture into various different things so you can actually enable monitoring and logging, security, integration with your existing tool sets. Cool. All right, so let's get some demos going. So first thing I'm going to do is we're going to start very simple. How's that looking for everyone? It's too small? Okay. How's the dark theme going for you? I've received some negative feedback around dark theme, but everyone's okay? Dark theme's awesome. I get criticism for light theme. For those when I use light theme, I also get criticism for dark theme as well. Anyway, besides the point, review me as you will, there's no pressure. So a very simple way to get started with kind of sharing patterns for developers to consume really starts with private modules. So using Azure Container Registry, we can define bicep modules that we can share within our organization. So taking this as an example, this is all within one repository. It might be more common where you'll have a centralized repository for your modules, and then developers will connect their application to that. The way that they actually do that is just through bicep configuration files. So here, if I actually go into Azure, open up the repository, and I will go in a little bit as well. So there I've got basically in my repositories, these are all different modules or bicep modules that I've pushed into my container registry. And then when I go back into my bicep configuration file, I'm then configuring an alias to that particular container registry. So when I go into my main.bicep file, I'm actually calling that particular module that's hosted within that container registry. Excuse me. Authentication to that is done through the Azure CLI, so as long as I have permissions to be able to read stuff from that container registry, I can use those modules within that bicep, within my main.bicep file. So rather than having to build all of these from scratch, imagine they're sitting in another repository, and then this application folder is another repository. Here I'm just calling modules that have been pre-made for me. So you can think about what kind of configurations you need from a networking perspective, RBAC controls, etc., rather than a developer having to kind of build that themselves. Calling modules is a good way to standardize those good practices across different teams. And it's more manageable if you're particularly in smaller teams as well. So that's a good example of private modules. So now what I'm going to do, I've never done this before, I'm going to change to my work computer, if you're on. Hello, it's me. And talk a little bit about Azure deployment environments. So Azure deployment environments are really our kind of answer to Backstage, I think, from an infrastructure perspective. So essentially, you'll have a bunch of modules that will sit in something called a catalog. And catalogs can be Azure repositories and also, where are you? There you are, GitHub repositories as well. So hopefully that's coming through okay. It's not. It is now. It was awesome. You were saying it a second after he was giving me the thumbs up. It was awesome. Okay, lovely crowd. Is that okay with the Zoom? I'll just zoom in a little bit as well. Okay, so the great thing about DevOps and Azure deployment environments, they share the same resource in Azure, which is a dev center. So you set up your dev center, and the idea is you may have different environments. So let's hope the environments work. So you may have non-production, production, dev, UAT, production, whatever you call your environments, and you can declare those within your dev center. You may have different projects as well for different teams. This is really good for exposing specific templates, whether that be Azure infrastructure templates or DevOps to particular projects. So you may have one DevOps configuration for team A, another for team B. And essentially, you also have catalogs as well. So one thing that I've got here, I've got this catalog here, which is sitting in my GitHub account. And then from here, we can essentially define templates that we want to expose to other people. So here, this is an application called BioTracker. This is my health and fitness app. I'm wearing a Fitbit. I have this application sitting in Azure that's doing some like data retrieval from it and doing all kinds of good stuff. This is the basic infrastructure that I need to deploy that particular application. So we've got different things like a Cosmos DB account, container app environments, normal container apps, etc. And then we expose that through a YAML file. And this essentially tells Azure deployment environments what properties we want to make available to our developers when they're creating stuff in provisioning new test environments. So what I can do here, if I go into the developer portal, so devportal.microsoft.com, and I'm going to have to change tenants as well. That's fine. Yep, have to go to non-production because I don't have access to production, unfortunately. And then this should show me, here's stuff I've provisioned earlier. So this acts as kind of like your catalog to provision new or create new environments for your developers. So imagine I'm a developer and I want to go ahead and create another test environment for my application. I can go and click new environment, and I'm going to go BioTracker test 02. I'll just use that for now. I can choose which environment I want to deploy to, so it could be a non-production environment, and then we've got an application definition. So everything that's exposed within your catalog, within here, this can sync into your dev center and then is exposed through here. So if I go ahead and just click BioTracker Starter app, that will expose the definition or the basic infrastructure that I need for my application. We can also schedule deletion as well, so we can do a little bit of a cleanup here. So if I go into deletion date, I can say, okay, I want to delete this at 2 o'clock, and we can set a time zone to that. We can also do this programmatically as well. There is a CLI that kind of works with this. So if I click next, I can go ahead and give a test name, so NDC Melbourne 2, environment, I'll say this is UAT, and location to Australia East. You can define defaults for this as well. So if you only want to provide give the developers the ability to select an application name or environment, you can do that. This is all exposed through that YAML file there. So you can do also pre-configure or select drop-downs for specific parameters. So a good example for that, if I go into simple container app, look at the environment, I can define some allowed variables as well for that. So you can actually limit what kind of resources your developers can deploy. And this is good for application SKUs. You don't want them to develop premium SKUs and then just forget about it and it's just burning money somewhere. So back in the developer portal, I'm going to go ahead and create that. That does take some time. I'm not going to make you sit through infrastructure deployment, but essentially here's something that I created earlier. So if I actually click on environment resources, what that will do within my Azure subscription, that will go ahead and deploy a new resource group with all the resources required for that that have been defined in that template. So now as a developer, I've got my own kind of sandbox environment that I can use to test my application code against a remote target. And there could be a little bit of cleanup as well for that. So you can enable that cleanup. Apologies. Awesome. Now, one thing that I will more show rather than kind of go through the detail, because it is very extensive, is this AKS platform engineering environment. So this uses the GitOps bridge pattern to actually deploy kind of a platform for you on AKS. So there's a whole thing in here. This is on Azure Samples as well, so you can fork it, and this builds kind of an internal developer platform using AKS like CAPS or Crossplane. And essentially what that kind of looks like, make sure if I go into, the great thing about using a trackpad, I also lose the trackpad very easily. So what I'm going to do is just port forward to my Argo CD server, go from here, and then I can actually essentially use kind of a GitOps pattern to understand, what applications are being deployed within an environment. So here I've got a store application that's been deployed. Hopefully that loads correctly and I can see the underlying services. This is really useful for when you're defining your infrastructure configuration within your GitHub repositories and you want to ensure some consistencies. What's in your Git repos is what's been deployed. Argo CD is a GitOps tool that can help enable that as well. And we can also look at kind of their cluster configurations as well. So I can see which clusters have been configured for this. And these are all deployed as Azure resources as well, but it's using Argo CD to act as kind of your GitOps operator as well. So go ahead and have a look at that. There's all kinds of different samples here on onboarding new developer teams, deploying Backstage as part of it if you want to have that service catalog capabilities for your clusters. But really, this is kind of the enterprise, very complicated end state that some of enterprises will need. A lot of this can be made simpler using private bicep modules, using tools like Azure Deployment Environments, depending on your team size. It's all about what tools you are familiar with, what you can manage as a team as well, because it's not just about building platforms, we also have to maintain it and iterate it as well for our customers in mind. Awesome. So just to recap, do another quick change. I'm relying on all of you, not just the tech guy, to give me the thumbs up to make sure everything's okay. As we wrap up here. Awesome. So kind of the takeaway today, it's when it comes to platform engineering, it's all about enabling our developers to deploy quicker with guardrails in mind, so they can self-service the tools that they need to complete the work there and deliver value that they need to within the guardrails of their organization. So this includes onboarding, this includes governance as templates, using kind of everything as code pattern if you can to implement governance, security in a language that they can understand, sharing APIs across the organization through service discovery, and being ensuring that we can actually discover services that exist across our organization in a quicker manner. And really your engineering platform becomes the product and developers are your primary customer, with input from security, architecture, and operations to iterate and ensure that your platform is meeting the needs for your organization. No matter where you are kind of on your platform engineering journey, you will kind of be involved in this cycle. So you may have the luxury of being able to start right. You may have to look at it from a more brownfield perspective and get right and actually get to an end state. The great thing about this is this never ends. There's always, because the cloud is a moving target, there are new things to be mindful of, new security threats. AI might be a thing over the next couple of years, who knows? So we need to keep all of that in mind and actually iterate on our existing platform. Now, a shout out to Dylan's event tomorrow, Dylan's talk tomorrow. I've touched very briefly and taken a very opinionated view on platform engineering. You know, I have a salary that needs to be paid. I've got a wedding that I need to pay for. So I've taken a very Azure specific focus on this. If you are a DevOps engineer, an SRE engineer, and you're still trying to figure out, okay, where do I sit in all of this? Please attend this session tomorrow. I understand it's going to be fantastic. I've been told that. There's no pressure, Dylan. But no, seriously, go and check it out. It's a great session. And thank you. Scan the QR code. The great thing about having a name like Will Velida is I'm Will Velida everywhere. No, it's a pretty unique name. I will be hanging around at the conference. I live in Melbourne. It's great to speak, do a hometown talk rather than travel to Sydney and suffer their coffee. If you have any questions, please come up to me afterwards. Thank you for your time.